Okay, so unit circle. So the main thing that I want you to think about, that I want you to understand and remember, is that when it's referred to as a unit circle because for convenience sake, we are basically forcing or saying that we're basically gonna transpose triangles onto the coordinate plane to create this circle, okay? For convenience sake, we are going to make, the reason why it's called a unit circle is because we are going to make the radius of this circle, which ends up being the hypotenuse of each of our right triangles. We're going to make this radius or the hypotenuse equal to 1. So we move 1 unit out. So that's the first thing to notice or think about or realize, is that on all of these, I've got 3 triangles down here, a triangle X, a triangle Y, a triangle Z. And I need you to imagine or think about the fact that we're drawing in this radius to create this triangle. We want the radius, or what ends up being the hypotenuse of all of these right triangles, we want that to be a unit of 1, and that makes our work a lot easier, and you'll understand why here in just a second. Okay, so keep that in mind, okay? So we're transposing, or basically kind of placing onto the coordinate plane these different triangles. So I need you to think about this. To begin with, I want you to think about this distance out this direction, and we move out a distance 1. So I want you to think about that coordinate, because it would be at 1, 0. And I want you to think about this point up here, which would be at 0, 1. So we have to figure out basically what the coordinates are in these other 3 special points that are on this unit circle, okay? And the way we are going to do that is by looking at these different triangles. So I need you to imagine this triangle X. So this triangle X is a 30, 60, 90. So this angle's 30, this angle's 60, and we've got that right triangle, that right angle there, that 90-degree angle. I need you to visualize. I've not ever been able to come up with a way of actually being able to slide the triangles up onto the coordinate plane the way I would love to. But I need you to be able to visualize taking this triangle, that 30, 60, 90 triangle, and sliding it up into that position here. So I want you to think about the fact that this, don't draw in the triangle up here. I'm going to draw it in, but then I'm going to erase it. Do not draw it in up there. It gets too busy if you do. But I need you to visualize this triangle X being transposed into that position there, okay? So I want you to think about the fact that we know then this particular point there is at 30 degrees. If we've transposed this triangle and slide it up into that particular position. We also know you need to have memorized by now. If you haven't, you need to start getting it memorized. 30 degrees is equivalent to pi over 6. Remember, pi is 180 degrees, and 180 divided by 6 gives us 30. So you've got to have those radian measures memorized and the degree measures, okay? So 30 degrees. Don't draw in the triangle, just put in those
30 degrees.
Yeah, just write in that 30 degrees, write in that radian, and we're going to put the coordinates in there in just a second, okay? So I need you to think about what we know about a 30, 60, 90. What's the relationship of the sides? So think back to your geometry days and your special triangles. And we know that the relationship is that it's a 1 square root of 3, 2. All right? So that's for our 30, 60, 90 triangle. Now the issue is, in this particular case, it's telling us that our hypotenuse has to be equal to 2. But we want the hypotenuse to be equal to 1. For convenience, we're having all the hypotenuse, or the radius in this case, equal to 1. So what would we have to divide by here in order to?
100.
Yeah, so we got to multiply by a half, or we've got to divide each of these particular sides by 2 in order to get a length so that our hypotenuse is equal to 1. Okay? So what that implies then is that the side opposite the 30-degree angle, which would normally be the 1, now has to be a 1/2. And the side opposite this 60-degree angle, which would normally be a square root of 3, has to be a square root of 3 over 2 in order for us to have our hypotenuse or our radius of the circle to be equal to 1. So what that corresponds to then is if we translate this triangle up into this position up here at 30 degrees, that means that the coordinates at this, visualize this is our distance going out this way and then up to get to that point. So I want you to think about the fact that what that's telling us then is that the coordinates at this point at 30 degrees, the coordinates are square root of 3 over 2, comma, 1/2. Okay, so the square root of 3 over 2 is this distance along the x-axis that we're moving, and then we're going up 1/2 to get to that particular point right there. Okay, questions or comments about that? You see visually how that's getting transposed up to that spot and how that's the coordinate? Okay, second point here, we want to look at this triangle Y. So similarly, if we were to look at this particular triangle, we've got a 45-degree angle here. That means this other angle is 45 degrees, so we have our special 45, 45, 90 triangle. We know that the relationship with the sides, going back to our geometry days, we know that the relationship is 1 square root of 2. So that's one of the triples I reminded you to memorize, and that's one that you worked on in geometry class, right? So 1 square root of 2. So now, once again, our issue is the same as it was before. We want our hypotenuse, or the radius of the circle, if we're thinking of this as a circle rotating around, we want that radius to be equal to 1. So what have we got to divide each of these by? What do we have to divide square root of 2 by in order to get 1? Square root of 2. So we have to divide this by the square root of 2, this by the square root of 2, and this by the square root of 2. So this gives us our 1 for our hypotenuse, so we're good to go there. But what that's telling us is that each of the lengths of these sides is equivalent to this 1 over the square root of 2, only we, as you know, mathematically we can't let that square root of 2 be in the denominator. So we have to rationalize that. So when that rationalizes, that gives us a square root of 2 over 2 and the square root of 2 over 2. So those are the lengths of each of our sides. And then we have our hypotenuse, which is equal to 1. If we slide that triangle up into position here, into this particular place, then we know at this 45-degree angle, or pi over 4 radians, that our coordinates have to be, if you think about what the coordinates are here, it's the same for each of them, so that makes it a little bit easier. So the coordinates at this particular point are square root of 2 over 2, comma, square root of 2 over 2. Okay. All right, and then last one, we haven't talked, I need to go back, I just realized I did not. I was just getting so excited to get started that I didn't talk to you about what the degree measures are and the radian measures are at these basic points. We know we're at 0 degrees here, that's our starting standard position, and that means that we're at 0 pi, We can also think about rotating all the way around, and we can say that that's 2 pi also. But for now, since we're talking about 0 degrees, we're going to say that's 0 pi. And up here, we know we're at 90 degrees, and we're at 180 divided by 2. In other words, pi over 2 for the radian measure. Okay. All right, lastly, we have this triangle Z, and in this triangle, here's our 60-degree angle, here's our 30-degree angle. And we're going to do kind of similar processes what we've been doing here. So we know our 30, 60, 90 triangle is this 1 square root of 3, 2, only now we've got to divide each of these by 2 in order to have a unit circle. So in order to have our hypotenuse be equal to 1, we have to divide by 2. So we've got to label these sides correctly, though, because the side opposite the 30 degrees is where the 1/2 goes. And the side opposite the 60 degrees, I wrote this a little too close to that, didn't I? Well, come on. Okay, there we go. The side opposite the 60 degrees is going to have to be the square root of 3 over 2. Okay. So if we slide that triangle, imagine sliding that triangle Z up onto that coordinate plane up here. So that's going to put us at this particular point. So that would be at 60 degrees, which is equivalent to pi over 3. And then let's write in our units. If you look, along the x-axis is 1/2. Along our y-axis, or going up to get to that point, is that square root of 3 over 2. So the coordinates here are 1/2, comma, square root of 3 over 2. Okay. So, in a nutshell, to go back and kind of review what we have just created here, we're going to focus our attention today on just quadrant 1. I think it's helpful if you can focus your attention on quadrant 1. And tomorrow, part of the video that you're going to see is a way to help you kind of understand how you can put together this unit circle and fill in all of those points. I'm going to show you a little trick here in just a second too, but it's all about different patterns. And some of this, like I said, you just have to get memorized. So you've got to know. If you know pi is 180 degrees, then pi over 6 has to be 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And pi over 2 is going to be 90 degrees. If you don't have those memorized yet, you got to get those memorized. Okay? All right. So that's kind of what I would refer to as basically the basics of creating the unit circle and filling in the unit circle. But now I also need to explain to you how and why we're going to use this, how this is helpful. So that's what we've got to talk about next. All right, so keep in mind our radius is 1, right? So, the other key point to remember and get memorized is the fact that the beauty of this and why we want to know this unit circle is to help us find the different trig functions at these different values. So just looking at these particular coordinates is going to help us with stating what the sine or the cosine or the tangent of the different values are. So here's what you've got to remember. I like to write this as, you have your coordinate point there as x comma y. So the other reminder is that what you're going to remember is that means you're given the cosine value corresponds to the x and the sine value corresponds to the y. We actually talk about the ratio of cosine and sine We know the sine has to do with, let's go back and let's take a quick peek at this. Right? If we are looking at this 30-degree angle and we're talking about the sine, then we know its opposite, which would be this side, over the hypotenuse, which is this side. So the beauty of forcing this unit circle to be 1 unit long is that our hypotenuse being 1 means all we have to look at is just this y value. So that's why I have written up here just the fact that you've got to remember that the cosine value is the x, the sine is the y, because if we do opposite over hypotenuse and our hypotenuse is just 1, then really it's just the opposite side. Okay, so that's the beauty of the radius or the hypotenuse being equal to 1. I want you to think about that with respect to the cosine value. If we look at any of these particular triangles and we think of our reference angle, if we're looking at the cosine value, the cosine is the adjacent, which would be this x side, the side along the x-axis, over the hypotenuse, which is 1. So in other words, we just have to state what the x-coordinate is. So that's why it's helpful to remember that in the form of x comma y in the unit circle, the cosine value will be our x, the sine value will be our y. I want you to think about the tangent ratio. So that's the last one. Let's look at that. If we look at this particular angle as our reference, the 60-degree angle, if we talk about the tangent ratio, we know the tangent is the opposite over the adjacent. So I want you to think about what locations those are in relation to x's and y's. So for the tangent being the opposite over the adjacent, the opposite side is which side, the x or the y?
Y.
Say it again?
The Y.
The y. So the opposite is the y and the adjacent is the x. So you do have to remember then that the tangent, to find the tangent value, you're going to do y over x. That is equivalent to our opposite over adjacent. Okay? All right, so I'm going to give you, I want to share some examples with you, and then I'm going to ask you guys to help me out with these. Okay? All right, so look at your unit circle. So let me explain here. If I ask you to tell me what the sine of 0 degrees is, then that means you're going to go to 0 degrees and you're going to look at because it's a sine value, we're going to look at the y-coordinate, and the y-coordinate at 0 degrees is equal to 0. So you have to go to the degree measure or the radian measure. You might be given either one. And you have to think about what the trig function is telling you are going to look at. So the sine means we're going to look at the y-coordinate. If I ask you as an example to tell me what the cosine of 60 degrees is. So we've got to go to 60 degrees.
1/2.
Yep, there you go. So at 60 degrees, we're looking at the x-coordinate because that's the cosine. So the cosine of 60 degrees is 1/2. Okay. Winston, what's the sine of 30 degrees? 1/2, yes. And Cleo, what's the cosine of 45 degrees? So go to the 45-degree coordinate, and for cosine, are we going to look at the x or the y? Cleo, are we going to look at the x or the y for the cosine? What have we got up here? Okay, so we're going to look at the x-coordinate at 45 degrees, and we know that the x-coordinate at 45 degrees is equal to? There you go, you got it. Square root of 2 over 2. Perfect. Okay. These take practice, right? Getting a little bit more comfortable and just remembering, okay, cosine is the first, sine is the second. The way I like to remember that really is, we know C comes before S in the alphabet, so cosine is going to come before sine. If you think visually about your triangle, it makes sense also, but just for quick reference, if you're having to go back and review, I think that's helpful. All right, what about the sine of pi over 2? Jorge? So I'm switching to radians, so you got to find that radian measure. And for sine, are we going to look at the x or the y?
Y.
Okay, and the sine value at pi over 2 is what, Jorge?
1.
1. There you go. Okay. Ryan, what about the cosine of 0 pi?
1.
Yep, that is 1 also, isn't it? Okay. I'm running out of room here. I don't want to write too much over. All right, I'll scoot up here. What about, Winston, the sine of 45 degrees?
45. Square root of 2 over 2.
Square root of 2 over 2, sounds good. And Ellie, the cosine of 30 degrees?
Square root of 3 over 2.
Okay, square root of 3 over 2. What about Chris, the cosine of pi over 2? 0, yep. And let's see, the cosine of pi over 6, Sloan?
Square root of 3 over 2.
Square root of 3 over 2, sounds good. I feel like I'm repeating, but I'm not, I don't know if I am or not. Okay, sine of pi over 3, Brady?
That would be root 3 over 2.
Sounds good, root 3 over 2. And the, let's see. How about the cosine of, what have I not done? I feel like I've done all of them. Probably not, I probably missed something. Coco, what's the cosine of pi over 3?
1 over 2.
1 over 2. Okay. Questions on that in terms of deciding on how you're using that for your sines and cosines? Because now I've got to show you your tangents. There's kind of some tricks with those that I want to make sure you're familiar with. I'm going to erase this for now just so that I have a little bit more space for writing these tangents and explaining those. So give me a second. Don't erase yours. Keep those on there. You're going to want that as reference. But I want you to have some, I want you to be able to see my iPad's tired and cold this morning too, I guess. Okay. So we decided that to find our tangent ratio, we have to do y over x. So to do our tangent ratio, we do y over x. So I want you to think about and notice what happens with those ratios. If I ask you to find the tangent of 0 degrees, if we do y over x, that means we're doing 0 over 1, and we know that that's just equal to 0. Okay? I'm going to write this in radians just because you got to kind of get used to those radian measures. So I want you to look at the tangent of pi over 2. So at pi over 2, or 90 degrees, if we do y over x there, we've got 1 over 0, which is equal to what?
undefined.
Yeah, that's undefined. Good. Okay, I want you to, there's a kind of a trick with the tangents. So just watch for a minute. Do not write anything. I want you to watch, okay? I'm gonna, to start this, I'm gonna show you, we're gonna look at the tangent of 60 degrees. If we look at the tangent of 60 degrees, this looks really messy to begin with because our y value is the square root of 3 over 2, and then that has to be divided by the x, which is 1/2. So we get this this complex fraction, right? We get fraction divided by a fraction. So there's a trick with this though, and that's what you've got to notice, okay? If we have complex fractions, we want to do the division here, but remember, dividing is the same thing as multiplying by the reciprocal. So if we have the square root of 3 over 2 divided by 1/2, if we do keep it, change it, flip it, then that becomes the square root of 3 over 2 times 2 over 1. Guys, what happens with the 2's? They divide out, don't they? And what are we left with then? What we're left with for our tangent of 60 degrees is just the square root of 3 over the square root of 1. I want you to notice where you see that in the original coordinates that we wrote. Okay, so notice and think about it. If you do that, keep it, change it, flip it business, these 2's divided out, so they just disappeared. So when you are doing tangent values of these middle values where you've got these fractions, you don't have to worry about the denominators because the denominators are just going to divide out. So you just focus, whoops, I'm not in highlighter mode. Let me try that again. Just focus your attention on the numerator of the y over the numerator of the x. That's going to give you your final answer, which that's just the square root of 3, right? So tangent of 60 degrees or tangent of pi over 3 is just the square root of 3. So let's talk about what that becomes here. The tangent of 45 degrees, let's use our trick. We're not going to look at the denominators. We're just going to worry about the numerators of our 45 degree. So what does that give us?
1.
Yeah, it does give us 1. There you go, Chris, because it gives us the square root of 2 over the square root of 2, which is just equal to 1. That's very special about the tangent at the 45 degree reference angle. And that 45 degree angle is that the tangent's going to just be equal to 1. So that's pretty easy also. Okay, all right, let's look at the last one. This is the trickiest of the bunch. If we want to do the tangent of 30 degrees, we want to look at the numerator of the y, which is 1, over the numerator of the x, which is the square root of 3. The tricky part is that you have to remember then to rationalize this, right? So the tangent of 30 degrees simplifies once we've rationalized to the square root of 3 over 3. Okay. All right. Questions, comments, thoughts? Okay, so that is how we find, and like I said, for now we are strictly going to focus just on this quadrant 1. This is how to find the sines, cosines, and tangents. Later this week, day 3, after you do your memorization quiz, we're going to talk about the reciprocal functions, the cosecant and the secant and the cotangent. But for now, we're just going to focus on cosines and sines and tangents. And just quadrant 1 for today. Tomorrow I'm going to share with you how you fill in the full unit circle using patterns that we learn about the 30, and the 45, and the 60-degree reference angle. So that's why it's just so important that you get memorized 30, 45, 60, your pi over 6, your pi over 4, your pi over 3, your pi over 2 for 90 degrees. Okay? All right, questions? Okay. There is a Quizlet that I would like for you all to try. And it is on Canvas. So keep that unit circle handy, that quadrant 1 unit circle. And once you finish with that Quizlet, there is a little bit more I'm going to do on a couple other pages based on what we saw, but I want you to try that Quizlet first, okay?